Hello everybody. Today I'm going to explain and derive how do you add sound pressure levels using the logarithmic decibel addition. So this is the common way to add sound levels since they can only be added logarithmically and not linearly. So for example, let's consider you have two speakers producing sound pressure levels S1 and S2. And let's say you're the observer standing at a distance of D from these speakers. You're going to be hearing a sound level which is not S1 and S2 but a combination of them. So in order to determine what is the actual sound pressure level that you'd be hearing, we need to perform some calculations. Let's get started. So this is the sound pressure level S1, which is given by this equation. S1 is 10 times log to the base 10, P1 by P0 the whole square. So P1 is the sound pressure which is measured in Pascal, whereas sound pressure level is measured in decibel. It is relative to the reference pressure, which is the 20 micropascal. So now what we're going to do is, in order to determine the total sound pressure level, we're going to have to add these values S1 and S2. So the total sound pressure that you hear as an observer is S1 plus S2. So now, if you can, add these things, it'll look something like 10 log to the base 10. So P1 by P0 squared plus P2 by P0 squared. As you can observe here, this equation is in terms of the pressure, which is in Pascal. But actually, I want an equation which is in terms of these, sound pressure levels. So what we're going to do is we're going to go back to this equation right here. So assume SI is 10 log to the base 10 Pi by P0 squared. Alright, so now I'm going to have to determine the value of this identity, like Pi by P0 squared, so that I can substitute right here. So, you can just like rework this equation out, so it'll be like, if I send the 10 here, it's going to be SI by 10. And if you take the logarithm to the other side, it becomes 10 power, because, it's to the base 10. And this equals to Pi by P0 squared. So now, as you can observe here, this value is equivalent to 10 power SI by 10. So if I equals 1, it'll be 1, and I equals 2, it'll be 2. So the final value that you can observe, it'll be S is 10 times log to the base 10, 10 power S1 by 10, plus 10 power S2 by 10. So this is the final equation. So here, the sound pressure level, the total sound pressure level is in terms of the sound pressure level of speaker 1 and speaker 2. So this is the equation you need to know in order to add and to find the total sound pressure level. So this is the logarithmic addition. So now this equation is not just valid for sound pressure level, it is also valid for sound power level. Actually, the sound power level equation is given by L equals 10 log to the base 10 W by W0. So if it's L1, it's going to be W1. So this is the reference power, and as it turns out, you try to find the value by manipulating here, you will still end up at the same value, except that this will be L and this will be W1 and W2. So this is the universal equation you need to know in order to add decibel levels. So now what's the significance of this equation? What does it mean to add these levels? It means that we have these two sources, two speaker sources. You're actually adding those levels because they're in phase, and the total value is going to be larger than the largest value. Alright, now that we have derived this equation, what is the significance of this equation? What does this plus symbol even mean? It means that the two sources, S1 and S2, are adding up constructively because they're in phase with respect to each other. So the total sound pressure level, S, is the logarithmic addition of S1 and S2, and it's going to be greater than the greatest value. Alright, thank you for watching. I hope you understood. Have a great day.